Important derivatives of naphthalene. First, naphthol. The hydroxy derivative of naphthalenes are known as naphthols. 1-naphthol and 2-naphthol. These are the structures of 1-naphthol and 2-naphthol. It is 1-naphthol is also known as alpha-naphthol and 2-naphthol is also known as beta-naphthol. In 1-naphthol, alcoholic group is present at first position and in 2-naphthol it is present on second positions. 1-naphthol is also known as S-naphthol. Preparations. 1-naphthol may be obtained from sodium 1-naphthalene sulfonate. When sodium 1-naphthalene sulfonate is fused with sodium hydroxide at 300 degrees centigrade temperature, it gives sodium 1-naphthoxide, and treatment of this with dilute sulfuric acid yields 1-naphthol. Next, from 1-naphthylamine. When 1-naphthylamine is treated with dilute sulfuric acid at 300 degrees centigrade temperature under pressure, 1-naphthol is formed. Properties. Physical property. 1-naphthol is a colorless solid. Melting point of the compound is 94 degrees centigrade. It is only slightly soluble in water but dissolves readily in ethanol and ether. Chemical properties. 1-naphthol resembles phenol in its chemical properties. Next, acidic characters. Naphthol is a weak acid. It dissolves in sodium hydroxide or sodium carbonate solution due to the formation of water-soluble sodium naphthoxide. The reason for the weak acidic character of 1-naphthol is that it ionizes in water to yield a resonance-stabilized naphthoxide ion. However, it is stronger acid than phenol. The increased acidity is due to the greater stability of the naphthoxide ion as compared to the phenoxide ion. In the naphthoxide ion, the negative charge is delocalized over two aromatic rings, whereas in phenoxide ion it is delocalized over one ring. Reaction with nitrous acid. 1-naphthol reacts with nitrous acid to give two oximes of 1,2-naphthaquinone, as you can see in the reactions. Next, sulfonation. 1-naphthol reacts with concentrated sulfuric acid at 40 degrees centigrade to yield a mixture of 1-naphthol 2-sulfonic acid. It is also known as Schoffer's acid, and 1-naphthol 4-sulfonic acid. It is also known as Neville Winder's acid. Both these sulfonic acid are used in the manufacturing of azo dye. Next, nitration. 1-naphthol it reacts with concentrated nitric acid and sulfuric acid at 20 degrees centigrade temperature to give 2,4-dinitronaphthols. The sodium salt of 2,4-dinitro 1-naphthol is known as Martius yellow, and it is used as dye for wool and silk. Reduction. 1-naphthol undergoes reduction with lithium metal in liquid ammonia to yield 5,8-dihydro 1-naphthols. It is also known as Burke reduction process. Oxidation. It is oxidized by chromium trioxide in acetic acid to form 1,4-naphthaquinone and by alkaline potassium permanganate to thelonic acid. Next, uses 1-naphthol is used in manufacturing of insecticide and dyes. Next, 2-naphthol. 2-naphthol is obtained by fusing sodium 2-naphthalene sulfonate with sodium hydroxide at 300 centigrade temperature. And sodium 2-naphthoxide is formed when on treatment with dilute sulfuric acid to yield 2-naphthol. Next, properties. Physical property. 2-naphthol is colorless and colorless solid. Melting point of the compound is 123 degrees centigrade. It is only slightly soluble in water but dissolves in ether and ethanol. Next, chemical properties. 2-naphthol resembles 1-naphthol in its chemical properties. Next, acidic character. Like 1-naphthol, it is also a stronger acid than phenol. It dissolves in sodium hydroxide or sodium carbonate solution to give water-soluble sodium 2-naphthoxide. Next, reaction with phosphorus pentachloride. 2-naphthol reacts with phosphorus pentachloride to give 2-chlorophenanthine. Next, reaction with nitrous acid. 2-naphthol react with nitrous acid to give one oxime of 1,2-naphthaquinone. Next, oxidation. 2-naphthol reacts reduces ammonical silver nitrate. It is oxidized by alkaline potassium permanganate to thelonic acid. Next, reduction. 2-naphthol undergoes reduction with sodium and isopentanol to give tetrahydro 2-naphthol or tetraenol. Uses. 2-naphthol is used for making dyes, as an antioxidant in manufacturing of synthetic rubber, as an antiseptic in the treatment of skin disease, for preparing its methyl and ethyl ethers, which are extensively used in perfumeries. Naphthylamines. The amino derivative of naphthalenes are known as naphthylamines. One naphthylamine and two naphthylamine. In one naphthylamine, amino group is present at first position, and two naphthylamine amino group is present at second position. One naphthylamine, it is also known as alpha naphthylamine. Preparation, it may be obtained by reduction of one nitronaphthalene with iron and hydrochloric acid by commercial method, and it can also be prepared by Bucker's reactions by heating one naphthol with ammonia and ammonium sulfate at 150 degrees centigrade temperature under pressure, and by heating one naphthol with ammonia and zinc chloride at 260 degrees centigrade temperature. Next, properties, physical properties. One naphthylamine is a colorless solid. Melting point of the compound is 500 degrees centigrade, turns brown or on exposure to air. One naphthylamine is only slightly soluble in water but dissolves readily in ethanol and ether. It has an unpleasant odor. Next, chemical properties. Basic characters. One naphthol is a weak base. pK of one naphthylamine is 3.9. It dissolves in acid to form the corresponding salt. Name of the compound is 1-naphthyl ammonium chloride. The reason for the weak basic character of 1-naphthylamine is that the lone pair of electron on nitrogen is involved in formation of delocalized bimolecular orbital and is not readily available for the formation of new covalent bond with proton. 1-naphthylamine is slightly weaker base than aniline. This is due to the more extensive delocalization in case of 1-naphthylamine. In 1-naphthylamine, the lone pair of electron which is present on nitrogen is delocalized over two rings, whereas in aniline it is delocalized over one ring only. As a result, the lone pair in 1-naphthylamine is even less available for the formation of new bond with the proton as compared to the aniline. Next, diazotization. 1-naphthylamine react with sodium nitrate in excess hydrochloric acid at 0 to 5 degrees centigrade to yield 1-naphthalene diazonium chloride. Next, sulfonation. 1-naphthylamine react with concentrated sulfuric acid at 140 degrees centigrade temperature to give 1-naphthylamine 4-sulfonic acid or naphthionic acid. Next, reduction. 1-naphthylamine undergoes reduction with sodium and ethyl alcohol to give aromatic tetrahydro 1-naphthylamine. Next, oxidation. 1-naphthylamine reduces ammoniacal silver nitrate. It is oxidized by chromium trioxide in acetic acid to form 1,4-naphthaquinone and by alkaline potassium permanganate to form phthalic acid. 1-naphthylamine gives a blue precipitate with ferric chloride. Next, uses. It is used in manufacturing of